Hello and welcome to Otten Math. In this edition, we're going to do some practice problems involved in graphing equations. The first problem asks us to find the slope of PT. Now PT is a tangent line to circle O. So we know that a tangent meets the circle at just one point, and we also know that if we draw a line from O to P, that segment is going to be perpendicular to the line PT. So the first thing we need to do is we need to find the slope of OP. And we do that using the slope formula. And we see that 9 minus 1 is 8 over 8 minus 3 is 5. So we come up with a slope of 8/5 for OP. Now we know that the slope of PT is going to be the opposite reciprocal. So all we have to do is flip the fraction and change the sign. So we get negative 5/8 as the slope of PT. In the next equation, or next problem, we're asked to verify the equation for PT. So we have the slope for PT. We just decided that it was negative 5/8. Now we have a point for P. We can use the point slope formula to figure out the equation for the line. So the point slope formula, y minus y1 is equal to m times x minus x1. All we need to do is fill in the values and rewrite in terms of y. So now I have y minus 9, 9 being my y1 variable, or my y1 value, my slope of negative 5/8, times x minus 8, and 8 is my x1 value. And here I have the equation for the line of PT. Finally, I'm asked to rewrite the equation for the line in point-slope form into slope-intercept form. So I have y minus 9 is equal to negative 5/8x minus 8. So I can rewrite that as y minus 9 is equal to negative 5/8x plus 5. So negative 5/8 times x is negative 5/8x. Negative 5/8 times negative 8 is going to be 5. And then I add 9 to both sides. I get negative 5/8x plus 14 as my equation in slope-intercept form. In the next problem, we're asked to verify or to find out the slope from A to B primed. B prime is just a reflection of B over the y-axis. So when I reflect a value over the y-axis, the distance from B to the y-axis is the same as the distance from the y-axis to B primed, its reflection. So you can see that the y component, y value stays the same at 9, but the x value will change. As I move 2 units over to the y-axis, I must again move another 2 units over to B primed. So I end up with a value of negative 2,9 for B primed. The slope from A to B primed will just be 9 minus 1 over minus 2 minus 10, which is equal to 8 over negative 12, or dividing both the numerator and denominator by 4, I get 2 over negative 3, or negative 2/3 is my slope. The next question, I'm asked to find the area of the shaded region. So I know that I have a circle that has a radius of 3 because the distance from the center, 0, 0, to a point on the circle is going to be 3 units, 0, negative 3. I have 3 units as my radius. So what I want to do is I want to figure out the area of the sector, and I want to subtract the area of this triangle here. So the area of the shaded region is equal to the area of the sector, which is the whole piece of pi, minus the area of the triangle. So the area of the sector is going to be 1/4, because I have 1/4 of the circle, of the area of the circle, which is pi times the radius squared. And then I'm going to subtract the area of the triangle, and the area of the triangle is just 1/2 base times height. I know the base and the height are both 3, so I have 1/2 of 3 times 3. So I end up with a value of 9 pi over 4, which is the area of the sector, minus 9/2, which is the area of the triangle. And that leaves me with a value And that is the value of the shaded region. In the final question, I'm asked to find the area of the regions 1, 2, and 3, and then finally to find out the area of triangle ODB. And so what I'm going to do is I'm going to find out the area of 1, 2, and 3, and I'm going to subtract the sum of those areas from the rectangle EC, we'll call this AO. So I figure out that the sector, or the triangle 1, is 1/2 of the base times the height, and we'll call ED the base. And I can see that the change from E to D along the x-axis is 6. And I can see the height is going to be 8, the change along the y-axis. So I end up with a 1/2 of 6 times 8, or 24, for my area, I should say units squared, for my area for 1. My area for 2, my base is going to be 6. This point is 10, 0. 6 to 10, so I change 4 units as my base, and I go from 8 to 3, so I have 5 units for my height. So 1/2 of 4 times 5, I end up with an area of 10 units for triangle number 2. Finally, for triangle number 3, I have 1/2 of the base, which is 10 units from O to A, times the height, which is from A to B, which is 3 units from 0 to 3, parallel to the y-axis. So I end up with a 1/2 of 10 times 3, or 15. So I sum these values, 24, 10, and 15, and I come up with a value of 49. And I subtract that value from the entire area of the rectangle. And the entire area of the rectangle is just the length, or EC, which is 10, times the width, which is going to be 8, or CA. So I have 80 minus 49 leaves me with 31 units squared.